Hello everyone, welcome back to Mathematics for Engineering 3. Today we are going to be talking about the second part of the techniques to Laplace transforms. Okay, in the previous video we have been talking about different techniques to do Laplace transforms, right? At the beginning we looked at the table, right? In the video before that, we looked at the table of formulas, right? And how to use those formulas to apply the Laplace transforms. And in the previous video, we looked at the technique. For example, what is the Laplace transform of t to the n f t? How would we do the Laplace transform for that function, right? And we also looked at the unit step function, right? And how to do the Laplace transform for the unit step function. The unit step function is the big U, right? And it's going to be 1, right? The U of t minus a is going to be 1 when t is bigger or equal to a, right? And if you don't remember any of these, just go back to the previous videos, okay? Or if you looked at all the videos and you still don't understand, you can just come and talk to me, okay? Cool. So today we are going to be talking about the period function. Okay, sorry, it's got stuck there. We're gonna be talking about the period function and how to do the Laplace transform for the period function. And what's more, we're gonna be looking at the convolution. Okay, first I'm gonna define what convolution is. Okay, and we're gonna do, of course, the Laplace transform for the convolution. Okay, so guys, let's start. First, let's look at the definition. Let f be a function defined on 0 to infinity and w is bigger than 0. The unit function f is called the function f is called a periodic function. It's periodic function, and w is called a period. If f t plus w is ft. Okay, f here is called a periodic function and w is called a period if ft plus w is ft. Okay, guys, I already changed the way I connect an iPad to the PC, so I believe it's going to be less latency. Okay, it's gonna be less lagging than what we had, and I hope it will be easier for you guys to understand the materials. Okay, cool. So guys, ft plus w is ft. Okay, that is the periodic function. Okay, what is periodic function? Is it looks pretty much like for example, psi x. If you see here, 0 here is 2 pi here, and then 4 pi, and blah blah blah. And as you can see, if I cut it here, it looks like that, right? And you see, if I cut it here again, at 4 pi, it looks pretty much the same. See, it looks pretty much the same. So the graph is repeated. Okay, it's repeated. Okay, it goes as it is and then is repeated. Okay, and that kind of function is called a periodic function. Okay, for example, for this function, w would be 2 pi. Okay, because every time when it goes t plus w is back to ft. For example, if t is pi over 4. Okay, if t is pi over 4, which is probably somewhere here. Sorry, somewhere here, right? Pi over 4. And if t pi over 4 plus 2 pi, it's gonna be somewhere here. And as you can see, they are exactly the same, right? If you look at the y-axis, they have the same value, okay? Which means that f of pi over 4 is the same as f of pi over 4 plus 2 pi, okay? Because the 2 pi is the period, okay? And f is a periodic function. Does it make sense? Okay. Okay. So if f is a periodic function, we would have that the Laplace transform of f would be 1 over 1 minus e to the minus sw integrate 0 to w e to the minus st ft dt. Okay, and that is the formula to find a Laplace transform for a periodic function. Okay, so let's look at some example. For example, this one, you want to find a Laplace transform of this ft, which is t and e to the 3t. Okay, and if you can see here, the function is defined from 0 to 4. Okay, it's defined from 0 to 4. Okay, 0 to 4, right? Because when t is 0 to 2, it's linear. Okay, it's linear. And when t is 2 to 4, it then exponential, right? It's exponential. I don't know what kind of graph it is, but it's exponential. Okay. And after that, when t is greater than 4, is a periodic function, which means that if you want to find f of 5, that f of 1 plus 4 is going to be the same as f1. Okay, so it's back to be repeated. So after 4, it's going to look like that again. Okay, and then it's going to be exponential again. Does it make sense? Does it make sense? So it's repeated, repeated. So this kind of function is a periodic function. It's a periodic function with the period equals 4, right? Because if you look here, ft plus 4 is the same as ft. Here, ft plus w is the same as ft. It means that w is actually 4. Okay, w is the period. Okay, so if I want to find a Laplace transform for ft, it would be, you look at the formula, is 1 over 1 minus e to the minus s, and w is 4, integrate 0 to 4 of, what is it, e to the minus st, right? E to the minus st ft dt. Okay, okay, and that is nothing, it's from the formula, right? When you substitute for w with 4. Okay, and then you get is 1 over 1 minus e to the minus 4s. And guys, if you look at the ft is defined differently. It defined differently from 0 to 2 and from 2 to 4, right? It's defined differently from 0 to 2 and from 2 to 4. Okay, so you need to change it to integrate 0 to 2 e to the minus t st t dt plus integrate 2 to 4 e to the minus st e to the 3t dt. Okay, Okay, and oops, sorry, e to the st. Okay, it's correct. And then you do the integration, right? You do the the just the integration for this one. I'm not going to do that, okay? Because to be honest, this formula to find the Laplace transform using this formula is not the good idea. Okay, we're gonna have an easier way of finding the Laplace transform for the periodic function. Okay, but anyway, right now we're gonna be using this. Okay, so I think you guys can integrate these two functions, right? For this one, for example, you can integrate it using the integration by part, right? You look at s as a constant, so it's basically e to the minus something t. So you can use integration by part to integrate this function. And this one is pretty simple. It's e to the 3 minus s t, right? E to the t minus s 3 minus s t. So it's e to the u. You can integrate e to the u. It's pretty simple. Okay, so I'm just gonna give you the answer, which is 1 over 1 minus e to the minus 4s, and here is 1 over s squared minus 2 over s e to the minus 2s minus 1 over s squared e to the minus 2s minus e to the minus 4s minus 3 minus e to the minus 2s minus 3 divided by s minus 3. Okay, and that is the solution. Okay, so if you don't know how to integrate these two functions, the function in green and in yellow, you can talk to me. I can send you the solution, how to integrate these functions. But anyway, I don't think it's a main point, okay? That is calculus one, right? Integrate using, integration by parts and things. Okay. Next, this example. Find the Laplace transform of ft, where ft is as in the graph below. Okay. Guys, just change it for me, okay? Is ft, not fs. It's ft, where ft is defined below. So it gives you the graph. Okay, it didn't give you the function. It didn't give you the function explicitly. So right now you need to somehow write down the function. Okay, you need to somehow write down the function. But as you can see, it's clearly is a periodic function, right? Because if you cut here, and of course here, they all look the same. See, it is repeated, right? It's repeated. So right now that is a periodic function with period equals 1, right? Because when it's 1, 2, 3, it's get repeated, right? So the period is 1, right? Here is 1. So you get the period of 1. Okay? And how to define this function? It's quite simple, guys. If you want to define these functions, you get ft equals, okay, you get ft equals, it's t if 0 to t and 1. And it's 2 minus t when it's 0, sorry, it's 1 t 2. Okay, so basically, you just define it for the first interval. just define it for, the yellow interval. Okay. Okay. Oops. Sorry, guys. It's a typo here. Can I change it a bit? Here, it's not 1, it's 2, and then it's 4, and then it's 6. Okay, so 1 is here, 3 is here, 5 is here. So my bad, sorry. So here, the period would be not 1, but 2. Okay, I put the wrong numbers there. So the period would be 2. My bad. So if it's 2, you just want to define the function only in the yellow panel, right? Right. So if you look here, basically you split this function into two functions. The first function is this function. It's this one, which is quite clear that is y equal x, right? Or in this case, the horizontal axis is t, and here is y, right? So here, this one is quite clear that is y equal t. Okay, that's why you get it here. Okay, let me write it down here. It's y equal t. Okay, y equal t. So from 0 to 1, you get y equals t. From 1 to 2, it's, it looks like this, right? It looks like this line, which is 2 minus t. Okay, it's 2 minus t. Guys, I'm not sure if you remember how to create a linear equation. You get y minus y1 equals m x minus x1. Here, it's quite clear that m is delta y divided by delta x, right? M here is, if you start from this point to this point, the first point is 1 1, right? This first point, this is 1 1. This point is 2 0. Okay, so if you get delta y divided by delta x, is going to be 0 minus 1 divided by delta x, which is 2 minus 1. That is going to be minus 1, right? So the slope is minus 1. Guys, this is the high school mathematics. Okay. Okay, so here, if you want to create a function y, you need at least one point, right? So I pick this point. Okay, I'll pick this point, which is 2 0. So it's going to be y minus 0 equals m is minus 1, x minus 2. So it's going to be y equals minus x plus 2, or 2 minus x. Okay, but right now our x is t, so we get 2 minus t. Okay, that's how to get the function. Okay, if you have the graph, how to get the function if it's linear. First, you need to get the slope, and second, you get, y minus y1 equals m x minus x1. That is from Matthew 4. Okay, when you do the cone, section, right? You learn the linear, the circle, and the parabola, the hyperbola, and some other things. Okay, guys, if you don't remember any of these anymore, so just let me know. Okay, we can talk about that. So this function, okay, the graph, it's actually ft equals t when t is bigger or equal to 0 and less than 1, and it's 2 minus t when t is bigger or equal to 1 and less than 2, and when t is bigger than 2, which is the period, right? We have that f of t plus 2 is the same as ft. Okay, so it's repeated. Okay, so we only write down this function for this period. But if it's f of 3, we look at f of 1 minus 2, which is f of 1. See, it's going to be the same as f of 1 because it's repeated. Okay, and if you want to write down the Laplace transform for that function, is going to be Laplace transform for ft is 1 over 1 minus e to the w, right? Uh, minus f w is 2, integrate 0 to 2 e to the minus ft dt, right? That is the formula, right? This formula, if you don't remember this formula. Okay, right now our w is 2. So here is going to be 1 over 1 minus e to the minus 2s, integrate 0 to 2 e to the, okay guys, again this ft is defined differently on two intervals. Okay, so it's going to be integrate 0 to 1 t e to the minus st t dt, plus integrate 1 to 2 minus t. Okay, let's put e to the minus st 2 minus t dt. Okay, so we split that into two integrals. Okay, but after that you integrate each integral. Okay, I'll just give you the result. Okay, I'm not gonna show you how to integrate them. Minus 2s. The first integration is we have minus t e to the minus st divided by s minus e to the minus st divided by s squared, and then we can substitute from 0 to 1. Okay, and the next one would be plus. Okay, this integral is this. Okay, that is the integral. You integrate that to get this. Okay, and then you substitute 1 and 0. And after that, the other one, it becomes t minus 2 e to the minus st divided by s plus e to the minus st divided by s squared divided by s squared, and then you substitute 1 to 2. Okay, and this is this integration becomes this. Okay, and guys, I'm not gonna do the whole thing, right? Because as I told you, it's not the main focus, but it's 1 over 1 minus e to the minus 2s, and then here we get 1 over s squared minus 2 divided by s squared e to the minus s plus 1 over s squared e to the minus 2s, and that's it. Okay, guys, you can try doing this yourself. Okay, try to integrate them. Okay. This is use integration by part. This is by part as well. Okay, so okay guys, this we need to multiply it like that, and here it's not by part, but here it's by part. Okay, you can try that yourself, but again guys, it's not the main focus. Okay, we're gonna be looking at how to do this integration again, but using different techniques. Okay, cool. So I'm gonna skip this example. Okay, so here is the main focus of the periodic function. Here is where you need to pay your attention to. Finding the Laplace transform of the periodic function using a unit step function. Okay, so if ft is a periodic function, okay, so the Laplace transform of ft can be written as that. And guys, it's not provided in the exam. You need to know. Okay, you need to know it yourself. Okay, guys, if you remember, if you go back to what we had before, okay, it's just here. If you have the periodic function, the Laplace transform of the periodic function looks like that, right? Right? Which is actually this one. Okay, I copy and paste it here so that you can make a comparison. Okay, so here is what we had before. Here is what we had before. Okay, it's 1 over 1 minus e to the minus hw integrate 0 to w e to the minus ht ft dt. Right? That's what we had before. And what I told you is not the main focus. Okay? I'm saying that this is the same as that. How? If you look here. Okay, guys. This part is the same. Right? They are the same. Okay? Ft is the periodic function. Okay? So they are the same. So LFT here are supposed to be the same. Okay? But here, down here, is the integrate from 0 to w. Okay? And here is ft. 0 to w of ft. Right? But up there is the Laplace transform of gt. Laplace transform of gt. Guys, what is the Laplace transform of gt? Is integrate 0 to infinity, right? E to the minus st dt dt, right? Right? Laplace transform of gt is integrate 0 to infinity e to the minus st gt dt, right? But why are they the same? Because one is integrate 0 to infinity and the other one integrate 0 to w. They are the same because gt is defined as ft when t is less than w. Okay, and it's defined as 0 when t is bigger or equal to w, which means that this integration is actually integrate 0 to w e to the minus st ft dt plus 0, because integrate from w to infinity is going to be 0 because gt is 0 on that interval. Okay, that's why they are the same. That's why they are the same. Okay, so to sum it up, if you want to find a Laplace transform of the periodic function, if you want to find a Laplace transform of the periodic function, first you look at the first piece. What do I mean by the first piece? For example, if it look like that, you only look at the first piece, when it's not repeated yet, which means that it's from 0 to w. Okay, from 0 to w. That is the first piece. Okay, and then you just find the Laplace transform of the first piece. Make sense? If you have, like this Laplace transform, right, is periodic and it goes on and on. So you just need to look at the first piece, which is this gt, right? It's defined as ft on this interval and it's 0 anywhere else. Okay, you only look at the first piece and then you just find the Laplace transform of the first piece, and the answer is 1 over 1 minus e to the minus sw Laplace transform of the first piece. Okay. It will get clearer when you look at the example. Okay, so actually these are not the main focus. Okay, these are like finding Laplace transform using definition. Okay, so they're not the main focus. That's why I went quite quickly and roughly. Okay, just to give you the idea. Okay, but here is where you need to pay the attention to. Okay, so let's look at some example. Okay, guys, for this one, we are asked to find a Laplace transform of ft, where ft is t when t is less than 1, and 1 and t is bigger than 1 but less than 2. Okay, here ft is defined from 0 to 2. Okay, it's defined to 2. But when t is bigger than 2, it is repeated, which means that it's a periodic function. Okay, so here if you want to look at the graph, it looks like that. When t is 1, it looks like that, and when t is 1 to 2, it's going to be 1. And then again, when t is bigger than 2, it looks like that again. Okay, so if you have 3, 4, 5, gonna look like that, and then it looks like that again, and it goes on and on. Okay, so it's a periodic function when w is 2. Okay, so before that, if before this, if we want to do the Laplace transform for this function, we would need to use this definition, right? And we need to do the integration, right, by parts, which is really hard to do and you don't really want to do, right? So you need to do the integration by parts, which is quite messy. So right now we're not going to use this theorem anymore. We're not going to use that because, as I told you, it requires us to do integration by parts, and it's quite messy. So what we are going to be using from now on for periodic function is this. Okay, it's that theorem. Okay, so here we would define gt as, of course, ft when t is less than or equal to and bigger than 0, right? Sorry, less than 2 and bigger or equal to 0, and 0 when t is bigger or equal to, right? That is ft. Make sense? Does it make sense? Or we can write it, differently, like that. It's going to be t when t is less than 1, and 1 when 1, t 2, and 0 when t is bigger than 0. Oh, sorry, bigger than 2. Okay, because why? Because gt is ft, right? Which means that we can split this ft into these two conditions. Make sense? And then the Laplace transform of ft is just, what is it? 1 over 1 minus e to the minus s, w is 2, right? E to the minus sw, right? W is 2. And then the Laplace transform of gt. And that's a lot easier to find. Why? Because it's 1 over 1 minus e to the minus 2s times the Laplace transform of gt would be the Laplace transform of t, and then you have u t minus 0 minus u t minus 1. Do you remember the step function, right? Sorry, the unit step function. If you don't remember, go back to the previous video, okay, when we talked about the unit step function, right? If we have t here, it means that it's t times u t minus 0 minus u t minus 1, right? 0 and 1 is from here. Okay, ut minus 0 and ut minus 1. And then we have plus 1. And then it's going to be u t minus 1 minus u t minus 2, right? U t minus 1 minus u t minus 2. And the last one would be 0. And I'm not going to write that down, okay? I'm gonna keep it like that. So we have 1 over 1 minus e to the minus 2s L of guys, I told you before, right? ut here, this guy is actually ut, and ut is always 1. Okay, so it's going to be 1 minus ut minus 1 plus sorry, 1 going to be t 1 minus u t minus 1 plus 1 u t minus 1 minus u t minus 2. Okay, and that is let me move this picture up here. Let's move this here, and then I'll move this picture up here. So so we have that this guy is 1 over 1 minus e to the minus 2s. Then you get the Laplace transform of t minus t u t minus 1 plus u t minus 1 minus u t minus 2, and that is 1 over 1 minus e to the minus 2s Laplace transform of t. Okay, we have the big the big parentheses here, and we have the, okay, let's do it a little slower. Laplace transform of t minus let's say plus 1 minus t u of t minus 1. This term is the sum of this term and this term. Okay, because if you multiply this, you get this term back. You multiply this, you get this term back. Okay, and then minus u t minus 2. So here it becomes 1 over 1 minus e to the minus 2s, and we have the Laplace transform of t plus Laplace transform of 1 minus t u t minus 1. Okay guys, this is 1. Okay, it's written badly, but I hope you know it's 1. Okay, so and the last one would be Laplace transform of minus Laplace transform of u t minus 2. Okay, I'll just copy these and I'll go to the next page. Okay guys, and how to do the Laplace transform for 1, 2, and 3. How to do Laplace transform for them. You need to go back, where we learned how to do Laplace transform for unit step functions. Do you remember? It's this theorem, right? the Laplace transform for t minus a ut minus a is e to the minus as Laplace transform of f. Okay, Laplace transform of f t minus a ut minus a is e to the minus as Laplace transform of f. So let's get back here and see how we can apply that theorem to this. Okay, first, Laplace transform of t, that should be simple, right? The Laplace transform of t, we have the formula for that, right? It's the same as the Laplace transform of t to the n, which is t to the 1, right? That is the Laplace transform of t to the n is n fact divided by s to the n plus 1. So you get 1 fact divided by s to the 2, which is 1 over s. Okay, so this one is done. It's simple. Okay, so now I'm gonna look at the next one, which is the Laplace transform of t minus 1 ut minus 1. So the Laplace transform of t minus 1 1 minus t ut minus 1 is the same as the Laplace transform of minus Laplace transform of t minus 1 ut minus 1, right? Okay, so if I let f star t be t, okay, so here is the Laplace transform of f of t minus 1 ut minus 1. Does it make sense? Because guys, ft is t, so ft minus 1 is t minus 1. Make sense? So ft minus 1 would be t minus 1. And then we can apply the formula that that we learned last time, which is Laplace transform of f t minus a u of t minus a is the e to the minus as Laplace transform of ft. Okay, Laplace transform of t minus a ut minus a is e to the minus as Laplace transform of t ft. We did that last time, okay, in the previous video. If you don't remember, go back to watch the previous video. Okay, so here it would be minus e to the minus a would be 1, right? 1s Laplace transform of f star t. Okay, Laplace transform f star t, and that is going to be minus e to the minus s. Laplace transform of f star t is, what is it? Laplace transform f star t is going to be Laplace transform of t, right? Because guys, don't forget f star t is t. Okay, it's t. So Laplace transform of t is 1 over s squared. Okay, we did that already. Sorry, 1 over s squared. So I got squared. 1 over s squared. So it's going to be minus e to the minus s over s squared. Okay, and that is done. The next Laplace transform. And the third one, this one. Okay, the third one is going to be Laplace transform of u of t minus 2. Is it the same as Laplace transform of f double star t u? Okay, let's do this first. 1 times u t minus 2. Okay, at ut minus 2 is the same as 1 times ut minus 2, right? And then if I let f double star t be 1. Okay, if double star t is 1, so if double star t minus 2 is also 1, right? Right? If double star t is 1, so if anything would be 1. If double star t minus 2, if double star 5, if double star 10, they are all 1, because if anything is 1. Okay, if double star anything is 1. So here I can write it as L of f double star t minus 2 u of t minus 2, and that is, okay, use this property, is going to be e to the minus 2s, right? As 2 Laplace transform of f double star t, and that is going to be e to the minus 2s Laplace transform of f double star. That will be Laplace transform of 1, right? Plus f double star t is 1. Okay, from here. So the Laplace transform of 1, if you look at the table, the formula is 1 over s. Okay, so if you put them together, here, you would have that is actually 1 over 1 minus e to the minus 2s. Okay, the first Laplace transform would be 1 over s squared. Okay, the next one would be minus e to the minus s divided by s squared. And the last one would be plus e to the minus 2s divided by s. Okay, and that is the solution. Okay, let me, oops, sorry, you can't see this. Let me sum this up. Okay, we want to find the Laplace transform for this periodic function. Guys, don't forget, here is the periodic function. Okay, if you want to find the Laplace transform for this periodic function, first we define gt, okay, which is ft on only the first piece from 0 to 2. Okay, because ft is defined from 0 to 2, and you know, when it's bigger than 2, it's periodic. Okay, it's repeated, right? Like that to 2, and then it repeated. It looks the same. See? So gt is ft only on the first piece. Okay, so it's the same as ft from 0 to 2. Okay, from 0 to 2. Okay, don't forget, right now our period is 2, and it's 0 when t is bigger or equal to. Okay, but ft is t and 1, so we can split this ft into t and 1. Okay, and guys, from this theorem, it says that the Laplace transform of ft is actually 1 over 1 minus e to the minus sa Laplace transform of g. Okay, and to do the Laplace transform of g, it's a step function, right? It's a step function. The g here is a step function. So we need to go back to the previous video. Okay, so it's going to be t. So if it's t, we have t here, right? And it's u t minus 0 and minus u t minus 1. Okay, if you don't understand why, you go back to the previous section, okay, the previous video, and then you get 1 here, and then you get u t minus 1 minus u t minus 2, and after that you get 0, blah blah blah. Okay, but 0 times anything is 0. I'm not going to be writing it. Okay, so here is, you need to know that ut is always 1. Okay, ut is the same as ut minus 0, which means that it's always 1. Okay, I explained that in the previous video. Okay, so here I just copy this, you know, uh, just do rearranging the terms, and I came up with this expression. So after that, I look at each Laplace transform separately. Okay, the first Laplace transform is simple. You can do it using the formula, the table, right? Laplace transform of L of t to the n is n fact divided by s to the n plus 1. And then the second one, you need to use this theorem. Okay, it's from the previous video. Okay, you need to go back and watch it. Okay, so it's L 1 minus t ut minus 1. So I pull minus out here, so I get minus t minus 1. Okay, and then I defined f star t to be t. Okay, so t minus 1 is actually f star t minus 1. Okay, so right now it fits this theorem. See, it's f t minus a, ut minus a. So a is actually 1. Okay, so in that case, we can write it as e to the minus as, right? E to the minus as, a is 1, don't forget. Okay, and Laplace transform of f, for this case, is going to be Laplace transform of f star. Okay, and Laplace transform of f star, but f star is t, so we put t in f star, so we get Laplace transform of t. So, but Laplace transform of t is 1 over s squared. So this is what we have. Okay, the next one, this one is the same. Okay, we need to apply this theorem. Okay, Laplace transform of ut minus 2 is the same as Laplace transform of 1 times ut minus 2. Okay, but guys, if I define f double star to be 1, so f double star t minus 2 is 1 as well, right? F double star of anything is 1. Make sense? So I can change this 1 here. I can change this 1 here to f double star t minus 2. And then it fits this theorem. Okay? ft minus a, ft minus a, ut minus a, ut minus a. So a here is 2. Okay? So we get e to the minus as, Laplace transform of ft, which is f star here for now. And then f star is 1. So we need to find the Laplace transform of 1, which is 1 over s from the table. Okay, and then we just need to plug in these, and these to the, to that expression. And then we get this, which is the answer. Okay, hope it's not too hard for you all. Okay, cool. So guys, let's look at the next example. So for this example, okay, we need to find the Laplace transform for this function, but the function is not known. Okay, so we don't really know the function, so we first need to write down the function. Guys, again, here it's ft, my bad, sorry. Okay, it's ft. Okay, so we need to find the Laplace transform for this graph. So first we need to write down the function. So guys, here you can see that for this interval, it looks like that, right? And then it's repeated, right? It repeated and it repeated again. Make sense? Which means that the period is 1. Okay, the period is 1, right? When it gets, the interval is 1, then it repeated, right? So the period is 1. Okay, so I want to define the function for this graph. Okay, so how to define the function for this graph? How to define the function for this graph? Okay, so first you need 2 points. You have 1 point here, which is 1 and 0, and you have 1 point here, which is 0 and 1. Okay, so whenever you have 2 points, you can find the equation, right? First, you need to find the slope, which is delta y divided by delta x. Okay, delta y is y of one point minus y of the other point. Okay, so I'm gonna begin with this point. So I get the y 0 minus 1 divided by 1 minus 0, and it's going to be minus 1. That is the slope for this line. Okay, and then you get y minus y1 is mx minus x1. So we have that is y minus, for y1 and x1, you just pick one of these points. Any point is okay. You can use this point or you can use this point. It doesn't really matter. Okay, so I'm gonna use this point. Okay, so y minus y1 is 0. Okay, y1 is this 0. Okay, 1 and 0, so y is 0, equals m is minus 1, x minus x1 is x minus, sorry, x minus 1. So we have y equals minus x plus 1. Okay, so we have y equals minus x. Oops, shit, sorry. uh Sorry guys, it's my bad. This point is not 1 0, right? Because 1 is here. This point is actually 0.50. Okay, so I'm not gonna use that point. Okay guys, let me redo it again. My bad, I'm so sorry. But it's a good practice, keep doing again and again. Here, I'm gonna pick this point instead, and that point. Okay, so this point is going to be 1 and minus 1. This point is 1 and 0 and 1. Okay, and then I'll find m again. M is delta y divided by delta x, and that will be minus 1 divided by delta x is going to be 1 minus 0. Okay, I get minus 1 here, minus 1 here. Okay, and 1 here, minus 0. Okay, that's delta x. Okay, delta y is y of one point minus y of the other point, and delta x is x of one point minus x of the other point. So we get minus 2. Okay guys, again, y minus y1 equals x, mx minus x1. So you have that is y minus, I'm gonna pick, okay, I'm gonna use this point, okay, because x is 0, at least it's supposed to be easier. So y minus 1 equals minus 2 x minus 0. So we get y equals minus 2x plus 1. Okay, so we have the equation for that graph. Okay, so then right now we can define ft as minus 2x plus 1. Okay, no, I don't need to have the, gonna have minus 2t plus 1. Guys, here we have x, y, and x, but here it's gonna be t, because the f is defined in terms of t. Okay, it's defined in terms of t. Okay, when t is less than or equal 1, bigger, sorry, when t is less than 1 but bigger or equal 0. Okay, and ft plus 1 is the same as ft. That is to tell that it's a periodic function. Okay, so right now we have the function. Okay, the function is not given, so we need to determine the function. Okay, so next we need to define gt, okay, which is ft when t is less than 1 and bigger or equal to 0, and 0 if t is bigger or equal 1. Okay, it's bigger or equal to 1. Okay, because guys, don't forget, right now our W is 1. Okay, next we would have that ft is minus 2t plus 1, right? Right, and 0. Okay, so we have that the Laplace transform of ft is actually 1 over 1 minus e to the minus sa is 1, right? Right. Sorry, w is 1, right, guys? Look here, we use this formula. Okay, 1 minus e to the minus ws. Okay, 1 minus e to the minus ws. Okay, so here we have that is s and w is 1, and then Laplace transform of gt. Okay, and that becomes 1 over 1 minus e to the minus s. Laplace transform of gt would be Laplace transform of, then we need to use the unit step functions, right? So it's going to be minus 2t plus 1 times u t minus 0 minus u t minus 1, and then plus 0. Okay, this 0 here is from here. Okay, it's plus 0 times t blah blah blah, but I'm not gonna write it. Okay, times ut minus 1, right? I'm not gonna write it because it's 0 times something. It's always 0, so I don't care. Okay, so here it is 1 over 1 minus e minus s Laplace transform of minus 2t plus 1 ut minus 0. I told you before, it's actually 1, right? Right, ut is always 1. So we have that is, it is going to be, that is 1 minus ut minus 1. Okay, okay, and let's go to the next page. 1 second. Okay, next, if you want to find the Laplace transform for this, is actually 1 over 1 minus e to the minus s, and then Laplace transform of, just distribute this in there, right? So you get minus 2t plus 1 minus minus 2t plus 1 ut minus 1. Does it make sense? Just distribute the left term into the basket. Okay, okay, so you're gonna have that is 1 over 1 minus e to the minus s, and then you have Laplace transform of minus 2t plus 1. Guys, can I multiply this in there? So I get plus Laplace transform of 2t minus 1, okay? ut minus 1. Guys, I hope it's not too confusing, okay? Because here it's actually 2t minus 1, right? Right, because if you multiply minus 1 in there, you get 2t and then minus 1. So you get Laplace transform of 2t minus 1 ut minus 1. Okay, so I'm gonna look at each of them separately. Laplace transform of minus 2t plus 1 is the same as minus 2 Laplace transform of t plus Laplace transform of 1, right? Don't forget, guys, the Laplace transform is the linear operator. So you can just, distribute it in, just find the Laplace transform separately. So here it's going to be minus 2 Laplace transform of t is t to the n, right? You use the table. T to the n is n fact divided by s to the n plus 1. So you get 1 fact divided by s to the 2. And then plus Laplace transform 1 is 1 over s. Okay. And then we look at the next function. Okay, we look at the next function. It would be Laplace transform of 2t minus 1 ut minus 1. Okay, which is this guy. Okay, and then here can I write like this, 2t minus 1 plus 1 ut minus 1. This is okay. If I minus 1 and then I plus 1, it's the same as to plus 0, right? So it doesn't really matter. Okay, so it's going to be Laplace transform of 2t minus 2, okay, and then plus 1 ut minus 1, okay, and that is Laplace transform of, guys, I grouped these two terms together, okay, and then I distribute it there. Okay, so I have 2t minus 2 u of t minus 1 plus u of t minus 1. Okay, and that is, that is Laplace transform of 2t plus 1 plus, u 2t minus 1 ut minus 1 plus Laplace transform of ut minus 1. Okay, makes sense? And that is 2 Laplace transform of t minus 1 ut minus 1 plus Laplace transform of ut minus 1. Okay, and guys, for this one, I can look at this as ft. Okay, so I need to let f star t be ft. Okay, and for this one, I actually have 1 here, right? 1 here, right? So I can let f double star t be 1. Okay, so I can write this down as 2 Laplace transform of f star t minus 1 ut minus 1. Make sense? Okay, it's the same trick, guys. It's the same trick. Laplace transform of f star t minus 1. Because, guys, it's a typo here. F star t is t. Okay, so f star t is t. So f star t minus 1 is t minus 1. That's why I can write t minus 1 as f star t minus 1. Okay, and plus Laplace transform of f double star t minus 1 ut minus 1. Okay, does it make sense? Because why? Because you have 1 here, right? But f double star t is 1. f double star t is 1. F double star t minus 1 is 1 as well. F double star box is 1. F double star anything is 1. So you can write down it as f double star t minus 1. Okay. And then we have the, we use the property that we used before. This one. Okay. Okay. This one is provided in the exam as well. Okay. It's in the table. Okay. So here we would have that is 2 1 over what is it? Sorry, it's not 1 over, is e to the minus s. S is going to be as, right? A is 1 and s, and then you find Laplace transform of f double star t, and then plus Laplace e to the minus a is 1 s Laplace transform of f double star t. Okay, it's the same trick. It's the one that we just used in the previous question. Okay, and for the first one, we would have that is 2 e to the minus s Laplace transform of f star is t plus e to the minus s Laplace transform of f double star is 1. So we have 2 e to the minus s. Laplace transform of t is s t to the n, right? Laplace transform of t to the n is n fact. Sorry, it's 1 fact divided by s squared plus e to the minus s 1 over s. Okay. Okay. So we need to put this in there and this in there. Okay. Okay. So the solution would be, the solution here would be 1 over 1 minus e to the minus s. Okay. 1 over 1 minus e to the minus s. And then we have minus 2 over s squared plus 1 over s. Okay, from this. Okay, sorry, from this. Okay, and then we have this guy from that. So we have 2 e to the minus s divided by s squared plus 2 e to the minus s divided by s squared, and then plus e to the minus s divided by s. Okay, and that is the solution. Okay guys, the next topic is the convolution. Okay, let f and g be functions continuous on 0 to infinity, except on some finite points. Guys, this is typo here again, my bad. It's ft and gt. Okay, ft and gt be functions continuous except some finite points. The convolution of ft and gt is defined by f star gt. F star gt integrate is integrate 0 to t fx gt minus x dx. Okay, that is the convolution of g and f. Okay guys, note f convolution of f and g is integrate 0 to t fx dt minus x dx, right? If I let u be t minus x, so du is d, du would be minus dx, right? Don't forget, guys, t now is a constant, right? We have x is a parameter. Sorry, x is a variable. Okay, so x is actually to t minus u. Okay, so what we have here is integrate fx, it would be t minus u, t du, dx is minus du. Okay, and then if x is 0, if x is 0, okay, here, right here, it defined in terms of x. So if x is 0, if x is 0, it means that u is actually t. So it's going to be from t. And if x is t, you have that u is 0. So you have 0 here, which means that it's integrate t to 0. F t minus u du du, and you have minus here. Okay, but guys, the minus of the integral, you can swap the boundary, right? You can swap the between t and 0. So if I put the minus 1 here to this integral, it becomes integrate 0 to t f t minus u du du, and I can write it down as t f of t minus x dx dx, right? I can just change from from u to x. It doesn't really matter. It's just a variable, right? So it means that this is actually d star f x, right? Because it integrate dx ft minus x dx. Okay, that is g star fx. So what I'm trying to tell you is that the convolution of fg is the same as the convolution of gf. That's it. That is a note. Okay, so you need to know that the convolution of fg is the same as the convolution of gf. Okay, so guys, let's look at the convolution of these functions. First, the convolution of e to the 3t star e to the minus 5t. So it's going to be integrate from 0 to t, right? And don't forget, guys, this is ft, and I define this as dt. Okay, so we would have ft, which is e to the 3t. Okay, and then we have g of t minus x, t of t, oh sorry, fx, not ft, it's gonna be 3x. Okay, guys, ft is e to the 3t, so fx is e to the 3x. Okay, and guys, gt is e to the minus 5t, so t of t minus x would be e to the minus 5t minus x dx. Okay, that would be the convolution of e to the 3t and e to the minus 5t. Okay, and that is integrate 0 to t e to the 3x e to the minus 5t plus 5x dx. And that is, guys, we integrate dx. Okay, so we treat t as a constant. Okay, so I pull e to the 5 minus 5t out. Okay, I'm able to pull t to the minus 5t out. So it's going to be integrate 0 to t e to the 8x dx. Okay, and that is e to the minus 5t integrate 0 to t e to the 8x d8x divided by 8. Guys, don't forget d of 8x is 8 dx. Okay, so 8 here cancel out, so you get dx, the same dx. Okay, so here it is e to the minus 5t divided by 8, and the integrate of e to the 8x, the 8x, that will be e to the u du, right? So you get e to the 8x from 0 to t. So what you have is e to the minus 5t divided by 8 and e to the 8t minus 1. Okay, and that is e to the, what is it, 1 over 8 and e to the 3t minus e to the minus 5t. And I think that is okay. Okay, good. So right now is you just follow the definition, right? The convolution of f and g is integrate 0 to t fx t minus x dx. So here you want to find convolution of this and this. You let one be ft, you let the other be gt, okay? So it will be integrate. It doesn't matter. You can let this be ft and let this be gt. You also have the same answer, okay? So here is integrate. If you don't remember, it's integrate 0 to t fx t of t minus x, right? dx. So fx ft is e to the 3t. So fx would be e to the 3x, right? And then e to the g of t minus x, gt is e to the minus 5t. So gt minus x would be e to the minus 5t minus x. Okay, dx. And again, guys, you just split this term into two terms, and then we integrate with respect to x. So t is considered as a constant, so I can pull e to the minus 5t out, okay, like that, and I integrate this part. Okay, and that should be easy, right? It's calculus 1. Okay, so let's look at the next example. So I look at this as ft, this as gt. So convolution of f and g would be, what is it, integrate 0 to t fx t of t minus x dx, and that would be 0 to t fx would be x squared, right? ft is t squared, fx is x squared, times e to the 2 t minus x, right? gt is e to the 2t, gt e to the 2t, t minus x e to the 2t minus x, right? dx. Okay, and again, this is integrate 0 to t x squared e to the 2t times e to the minus 2x dx. Okay, and then I pull e to the 2t out because it is a constant. And then we have integrate 0 to t x squared e to the minus 2x dx. And guys, I think we all know that it is integration by part. Okay, it's integration by part, which means that we can integrate it using the integration by part techniques, right? So we have x squared e to the minus 2x. So we have 2x to 0. So integrate e to the minus 2x, you get e to the minus 2x. What is it? Integrate e to the minus 2x. Integrate e to the minus 2x dx. You need to get e to the minus 2x d minus 2x, right? And you get minus 2 here. So you get minus 1/2 e to the minus 2x, right? all right? And then you integrate it again, you get 1/4 e to the minus 2x, okay? And then we do this, if you remember the shortcut to do the integration by part, right? So we get 2x over 4 e to the minus 2x plus minus, right? Minus, sorry, we have minus here as well. And then we have, we get 2x times minus 1/2 e to the minus 2x, and then minus plus and minus, and then minus 2 1/4 e to the minus 2x, which is cancel out, so we get minus x e to the minus 2x minus 1/2 e to the minus 2x. Okay, so we put them here. So what we have is e to the 2t minus x e to the minus 2x minus 1/2 e to the minus 2x, and then 0 to t. Okay, so we have e to the 2t. If you put t, you get minus t e to the minus 2t minus 1/2 e to the minus 2t, and then you put 0. You minus 0, right? 0 times e to the minus 2 minus 2x, that will be 0, right? Minus 1/2 e to the minus 2 times 0 is 1, right? So you get only minus 1/2. So we have here is e to the 2t times minus t e to the minus 2t minus 1/2 e to the minus 2t plus 1/2, and that's it. Sorry, and that's it. Okay, for this question, we look at this as ft and this as gt. Okay, so we have ft is t squared, gt is e to the 2t. Okay, so the convolution of t squared and e to the 2t would be integrate 0 to t f x dt minus x dx, right, from the definition. And that is integrate 0 to t, fx would be x squared, dt minus x would be e to the 2t minus x dx, okay, e to the 2t minus x dx, and it will be integrate 0 to tx squared e to the 2t minus 2x dx, and we integrate with respect to x, so we treat t as a constant, so I can pull t to the e to the 2t out. So I get integrate 0 to tx squared e to the minus 2x dx. Okay, so then we need to integrate these. Okay, so we can use integration by parts. Okay, so we have x squared e to the minus 2x, diff is 2x, x, sorry, 2, and then 0. So here we integrate e to the minus 2x is minus 1/2 e to the minus 2x. Okay, integrate e to the minus 2x is minus 1/2 e to the minus 2x. I hope it's not too hard. Okay, you can try integrate that yourself. Okay, using the integration by substitution. Okay, and the next one will be 1/4 e to the minus 2x, and then minus 1/8 e to the minus 2x. Okay, and then we have that plus minus plus. Okay, so here, from here, we have that it is actually e to the 2t minus x squared divided by 2e to the 2x, and then minus 2x 1/4 e to the minus 2x and then minus 2 1 eighth, sorry, plus 2 1 eighth e to the minus 2x, and that is e to the 2t. What is it? Is minus x squared e to the 2x divided by 2 minus x e to the minus 2x minus 1/4 e to the minus 2x, and this is from 0 to t, from 0 to t. Okay, I hope you are able to do the integration by parts. Okay, and then we put the t 0 and t in there. So once we put t, we get minus t squared e to the 2t divided by 2 minus t e to the minus 2t minus 1/4 e to the minus 2t, and then minus you substitute x with 0, right? So you get 0 plus 0 minus 1/4. So what you have here is e to the 2t minus t squared e to the 2t divided by 2 minus t e to the minus 2t minus 1/4 e to the minus 2t plus 1/4, and that's it. Okay, hope is easy enough to understand. Okay. Oh guys, sorry, I have minus 1 here, got it. Okay, I can actually pull e to the minus 2t out, right? I think it's probably better to pull e to the minus 2t out, right? Okay, let's multiply e to the minus 2t in the basket. So we have minus t squared divided by 2 minus t divided by 2 minus 1/4, and then we plus e to the 2t divided by 4. Okay, I think that looks prettier. Okay, the next theorem, which is the last one for this section. Let f and g be functions, okay? And Lf, which is the big F, S is the Laplace transform of f. The big G is the Laplace transform of g. Okay, so the Laplace transform of convolution and of f and g is actually the Laplace transform of this, right? Because this is the definition of the Laplace transform of the convolution, right? Sorry, which is this the definition of the convolution. Okay, right? Convolution of f and g is integrate 0 to t fx gt minus x dx. Okay, and that is the Laplace transform of ft times Laplace transform of gt, which is big F times big G. That is a good thing. That is a good thing. Why? Because if you have the convolution, you need to find the Laplace transform of the convolution of f and g. What you need to do is just to find the Laplace transform of f, and then you find the Laplace transform of g, and then you multiply them. So you get the Laplace transform of f and g. Okay, that's pretty simple. Okay, again, if you want to find Laplace transform of convolution of f and g, you just need to find Laplace transform of f, you find Laplace transform of g, and then you multiply them together. Okay, it's pretty simple. Note, guys, if you want to find the Laplace transform of integrate 0 to t of fx dx, there's no g. Okay, there's no g. But can I write it like this? It's the Laplace transform of fx times gx, sorry, gt minus x dx when gt minus x is 1. Okay, it's a Laplace transform of fx times gt minus x. I don't even need gt minus x is 1. I can even write gt is 1, because if gt is 1, gt minus x is 1 as well, right? If gt is 1, g box is 1, gt minus x is 1, gt square is 1, g of anything is 1, because gt is 1. Okay, 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 guys. So this guy is 1, and that is the Laplace transform of f t times Laplace transform of gt. But gt is 1, right? gt is 1. So Laplace transform of gt is Laplace transform of 1, which is 1 over s. Okay, so you have the formula. Laplace transform of integrate 0 to t fx dx is 1 over s Laplace transform of ft. See, that's a good formula. Okay, and similarly, if you want to find Laplace transform of integrate 0 to t of f of t minus x dx, it's the same, guys. You can look at it as Laplace transform of 0 to t gt f t minus x dx. Okay, when you define gt as 1, again the same g. Okay, so that case you get Laplace transform of gt. Okay, guys, don't forget there will be Laplace transform of convolution of f and g x, right? Which is the Laplace transform of gx times Laplace transform of f gt times Laplace transform of ft. But Laplace transform of gt is Laplace transform of 1, which is 1 over s again. Okay, so you get 1 over s Laplace transform of ft. So this formula, Laplace transform 0 to t integrate 0 to t fx dx is 1 over s Laplace transform of ft, and is also the same as integrate Laplace transform of integrate 0 to t of f of t minus x dx. Okay, so basically, if you want to find Laplace transform of integrate 0 to t fx dx, or Laplace transform of integrate 0 to t ft minus x dx, that is 1 over s Laplace transform of f. Okay, that can be done by letting g be 1. Okay, and this guy is actually the convolution of f and g. So if it's Laplace transform of the convolution, you can split the Laplace transform. Okay, so on this page you need to know 2 things. This is the most important thing. The first thing, Laplace transform of f or convolution of f and g is Laplace transform of f times Laplace transform of g. That is a really good property. Okay, and Laplace transform of this or this is 1 over s Laplace transform of ft. Okay, so let's look at some example. Well, we want to look at Laplace transform of the convolution of t to the 7 and sine 4t. Okay, and that is quite simple. It's actually Laplace transform of t to the 7 times Laplace transform of psi 4t. Make sense? Right? Because Laplace transform of f, convolution of f and g is Laplace transform of f times Laplace transform of g. Okay, so you can split the Laplace transform. Okay, so here Laplace transform of t to the 7 is actually t to the n, right? So you get n fact s to the 8. Okay, t to the n divided by s to the n plus 1. Laplace transform of psi kt is k, which is 4, s squared plus k squared, which is 16. Okay, and that's it. Done. Simple, right? Right. Laplace transform convolution. You can split the Laplace transform. Okay. Okay, guys. Laplace transform of this. How to do Laplace transform of this? So, if you look at it closely, you can let f t be e to the minus t squared, and you let gt be 1. Okay. So this Laplace transform is actually Laplace transform of e to the minus x squared times 1, which is Laplace transform of fx, right? ft is e to the minus t squared. Fx is e to the minus x squared, right? Which is actually this guy. Okay, and then I can write gt minus x. Okay, because gt is 1, gt minus x is 1 as well. Okay, so oops, sorry, I forgot the integration side. 0 to t dx. So here I would have integrate 0 to t, and I would have dx as well. And this is the convolution of f and g. Okay, this is actually the note that we have. Okay, so it would be Laplace transform of ft times Laplace transform of gt, but it will be Laplace transform of ft times Laplace transform of e to the minus t squared times Laplace transform of gt is Laplace transform of 1. And what is Laplace transform of e to the minus t squared? You remember? We need to just find Laplace transform of t squared, and then we shift t to shift s to s plus 1. If you remember, it's e to the as, remember, e to the as, and then you shift s to s minus a. Okay, when a is minus 1 in this case. Okay, it's the first technique. Okay, if you go back to the previous video, it's the first one. It's the first technique. Okay, and then Laplace transform 1 is 1 over s. So here Laplace transform of t, that will be 2 fact divided by s to the 3. Then you change s to s plus 1, 1 over s, and that will be 2 divided by s plus 1 cubed, 1 over s. That's it. Okay, very simple, very easy. Okay. Next, find Laplace transform of this function. Okay, so this one you need to be able to see that if you let ft be cos 2t and gt be gt minus x is x minus t to the 5. Okay, so basically you're gonna look at this as gt minus x, and you look at this as ft. Okay, so we know that this guy is actually L of Laplace transform of integrate 0 to t ft. Okay, I swap this first, right? So cos 2x, that will be ft. Sorry, fx, my bad. Fx, okay, I swap that to the beginning, and then I have g t minus x dx. Okay, and that would be the Laplace transform of convolution of f and g, right? In that case, it would be Laplace transform of ft times Laplace transform of gt. Okay, and what is Laplace transform of ft? That should be simple, right? Laplace transform of ft, that should be simple, because Laplace transform of cos 2t, it actually s divided by s squared plus 2 squared, right? That is Laplace transform of that. And Laplace transform of gt, this is a little bit tricky. So it's x gt minus x. Okay, gt minus x is x minus t to the 5. Okay, this is the tricky part, guys. gt minus x is x minus t to the 5. Let me write it down here. gt minus x is x minus t to the 5. Okay, so can I write it as minus t minus x to the 5? Okay, because minus t minus x is x minus t, right? So it's minus x minus t to the 5. Okay, oops, sorry. Minus t minus x to the 5. So gt minus x is minus t minus x to the 5. So gt would be minus t to the 5. Make sense? You look at this as a box. You look at this as a box. So g rate is minus rate to the 5. See? gt minus x is minus t minus x to the 5. G red is minus red to the 5. G pink is minus pink to the 5. gt is minus t to the 5. Okay, so you need to find a Laplace transform of minus t to the 5. And that would be, what is it? S squared plus 4. Laplace transform of minus t to the 5. That would be minus Laplace transform of t to the 5. Right? And that would be minus s squared plus 4. Laplace transform of t to the 5 is 5 fact divided by s to the 6. And that is the answer. Okay, see? Very simple. Very easy. Okay? Okay. Next, the last example. T squared integrate 0 to t sine 3t minus 3x dx. Okay, how to do integration for this one? First, we need to use the second technique. If you remember from the previous video, we have the technique Laplace transform of t to the n ft. If you remember, Laplace transform of t to the n ft is, what is it? You need to find the second derivative. Remember, you need to find the second derivative of Laplace transform of ft. Okay, that's second technique in the previous video. So guys, you need to understand all the techniques, because you need to use one another. Okay, so it's not going to be one technique for one question. It's going to be a couple of techniques, or 3 to 4 techniques in one question. So you need to master all the techniques. Okay, so this one is the same as to find the Laplace to find the d by ds second derivative. Okay, we look at this as the fx in the technique. Okay, in the second technique. So we need to find the second derivative by s of Laplace transform of integrate 0 to t sine 3t minus 3x dx. Okay, and guys, I just gonna look at this guy first. Okay, just gonna look at the Laplace transform first. This will be Laplace transform of integrate 0 to t sine 3t minus x dx, right? Right. And if I let ft minus x be sine 3t minus x. Okay. Okay. Okay, guys. Okay. I'm not going to let gt be 0. Okay. I'm not gonna do that again. I'm just gonna use the note here. The note here. Integrate of Laplace transform of integrate ft minus x is 1 over s Laplace transform of ft. Okay, so here you would have Laplace transform of integrate 0 to t f t minus x dx is Laplace 1 over s Laplace transform of ft. Okay, but the problem is we don't know ft yet, right? We know ft minus x, but guys, again, ft minus x is sine 3t minus x. F red is sine 3 red. F pink is sine 3 pink. Ft is sine t sine 3t. So we have that ft would be sine 3t. So there will be 1 over s Laplace transform of sine 3t. And that will be 1 over s Laplace transform of sine 3t. That would be 3 divided by s squared plus 3 squared, which is 9. Okay, so this guy is going to be the second derivative by s of 1 over s 3 divided by s squared plus 9. Okay, and then we need to find that derivative. Okay, so let me rearrange the term a bit. So it's going to be 3 divided by s cubed plus 9s. Okay, s cubed plus 9s. So to find the derivative of that is going to be second derivative of 3 s cubed plus 9s to the power of minus 1, right? So let's find the first derivative first. So the first derivative would be minus 3 s cubed plus 9s to the power of minus 2, and then the chain rule, you get 3s squared plus 9. Okay, you get 3s squared plus 9. Okay, and that is actually minus 3. Okay, I pull minus 3 out, so I get minus 9 s squared plus 3 divided by s cubed plus 9s squared. Okay. 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 And then I find the second derivative. So you need to use the the relative of u over v, right? Which is low d high minus high d low divided by low low, right? Is v du minus u dv divided by v squared, right? That's the formula. So we have low d high. I get minus 9 out. Okay, I'll leave minus 9 out of it. D high would be 2s minus high, which is s squared plus 3. D low, oh, take lots of spaces. D low would be 2s cubed plus 9s, and then you have the chain rule. You get s 3s squared plus 9. Okay, divided by v squared. That would be s cubed plus 9s to the 4. Okay. Okay. And I'll copy this to the next page. Okay, here you would have that is minus 9, and in there is s cubed plus 9s squared. Okay, let me pull. We have minus 9, right? And I pull s cubed plus 9s out. Okay, I pull s cubed minus 9s out. So in there, we have s cubed plus 9s times 2s minus s squared plus 3 times 2 times s squared plus 9s s cubed plus 9s uh, and divided by s cubed plus 9s to the 4. So this cancel with this, so we get to the 3. Okay, guys, sorry, here I pull s cubed plus 9s out, right? So here I need to pull s cubed plus 9s out. So what we have left is 3s squared plus 9. Okay, it will be 3x squared plus 9. Okay, and then we have minus 9. In here we have 2s to the 4 plus 18s squared minus oh no, what is it? Is let's do it a little slower here. Is 2s squared plus 6, right? I multiply this to this. Okay, I get to 2s squared plus 6 and then 3x squared plus 9. So I would have 6x, sorry, it's s squared. I don't know why I wrote s squared. So we have 6s to the 4, and then we have 18 s squared, and then we have 18s squared, and then we have 54, right? Then we have 54. Okay. Okay, so we have 6 s to the 4 plus 18s squared. It's actually plus 36, right? 36s squared plus 54, and then divided by s cubed plus 9s to the 3. Okay, so we have minus 9. There will be minus 4s to the 4, right? Minus 18 s squared minus 54 divided by s cubed plus 9s. Guys, it's nothing. It's just just messy. You just need to. It's a labor work, okay? So you just need to rearrange the terms. Actually, it's all thing has already stopped here, right? When once you are able to find the second derivative, okay? And next, I pull the minus 2 out. So I would have 18 2s squared plus 9s squared plus, what is it? 25, 27 divided by s cubed plus 9s cubed, like that. Okay. And guys, that's it. That's done. Okay. And that is the end of the section 2. Okay. If you okay, let me summarize what we have learned today. We begin with the step function, right? We first look at the definition of the periodic function. We first look at the periodic function, and then I tell you to find the Laplace transform of the periodic function using this formula. Okay, but actually not this formula is not preferred. Okay, why? Because it's hard, right? It's hard. As you can see here, we need to find the you need to use the integration by parts, right, to solve this, and it's really hard. We don't really want to do that, right? I show you another example. We need to use integration by part here, and I even didn't do it because it's too messy. Okay, and after that, I give you another theorem saying that if you want to find a periodic function of a function f, okay, instead of using this theorem, the one that I told you before, no, we just define g in the first piece, right? Define g in the first piece when t is less than w, right? In the first piece, and then Laplace transform of the periodic function f is actually 1 over 1 minus e to the minus hw, and then you find Laplace transform of g. That is a lot easier. Okay, that's a lot easier. Good. So, for example, this one, right? We find f is defined from 0 to 2, like that. And then after that, it's repeated. It's the periodic function. So we define g as f on this interval. Okay, and then it's 0 otherwise. Okay, and then we split f into 2 functions, and then we apply this theorem. Okay, instead of integrating 0 to w blah blah blah, we just need to find Laplace transform of g. But g is the step function, right? The step function. So we can write it in terms of u. Okay, and then we use the theorem, the technique that we used in the previous video to find the Laplace transform of g. Very simple. Okay, Next, we look at the convolution. Okay, first is the definition. Convolution of fg is integrate fx gt minus x dx 0 to t. As simple as that. Okay. After that, we look at the Laplace transform of the convolution of f and g, and that is simple, right? If you want to find Laplace transform of convolution of fg, it's actually Laplace transform of f times Laplace transform of g. Very easy. Okay, and we have the note here that Laplace transform integrate 0 to t fx without g. It means that g is 1, and Laplace transform 1 is 1 over s. See? And if you want to find Laplace transform of t minus x, ft minus x, it means that gt is 1. And the same, Laplace transform 1 is 1 over s. Okay, so we have, some small note to work with to make our life easier. Okay, so right now we are done with the second section. Okay, so in the next video, I'm going to talk about the inverse Laplace transform. Okay, what inverse Laplace transform is. Okay, basically, if you have f, you can do the Laplace transform, right? Change it to LF, right? And if you change it to LF, if you have the LF, can you change it back to f? That is the idea of inverse Laplace transform. You have A, you take Laplace transform, you get B. If you have B, you need to take the inverse Laplace transform to recover A. Okay, and how to do that. So in the next video, we're going to be talking about the basic inverse Laplace transform and hopefully the inverse Laplace transform techniques as well. Okay, see you in the next videos, guys. Don't forget to do exercises, read lots of things. Okay, read watch all the videos, do exercises, and if you have any questions, don't hesitate to contact me. Okay, so bye bye, guys. See you.